So for this problem, we are going to be talking a little bit about dimensional analysis. Dimensional analysis is kind of a bigger term. So for this problem, we are going to be talking a little bit about dimensional analysis. Dimensional analysis is kind of a bigger term there, but basically what it's talking about is breaking down some of these equations, like, for example, v is equal to v0 plus at. The point of dimensional analysis is to break down this equation into its smaller components. So some of the smaller components are, for example, x is equal to distance, which is in meters. V is distance over time, which is meters per second. Acceleration is distance per time squared, or meters per second squared. Time is, of course, given in seconds. So for the first example, is example 1, v equals v0 plus at, dimensionally correct? In order to find out, we need to break this equation into its smaller components. So break the equation into components, or pieces. And we do that by replacing the v with meters per second equals v0, which is kind of like the initial velocity, which is still just in meters per second, plus the acceleration, meters per second squared, multiplied by the time, t, which is in seconds. Then cancel terms. And when you cancel terms, the seconds in the denominator can cancel with the seconds in the numerator and the at part of the equation, leaving you with meters per second is equal to meters per second plus meters per second. Because the meters per second plus the meters per second are just being added, that does not change the dimensions of the equation. So basically, you are left with meters per second is equal to meters per second. For the second problem, we have x is equal to v over 3a. So go ahead and break down this equation into its components. X is given in meters is equal to velocity in meters per second divided by, open parenthesis, 3 multiplied by meters per second squared, and then close your parentheses. Now for this one, you can remove the numbers, such as the 3. The 3 is not important to the dimensions. The letters, they all need to stay there, but the 3 can go away. Up in the power, the exponent for the second squared, that needs to stay there, because second squared means seconds times seconds. It's not actually a number that you should remove. So go ahead and leave that in there and just remove the numbers. And when you do that, you get meters equals meters per second divided by meters per second squared. Then, when dividing a fraction by another fraction, so the meters per second divided by meters per second squared, you can take the fraction that's in the denominator, or in the bottom, and you can take the reciprocal and multiply it by the numerator like this. So the new equation looks like s squared divided by m multiplied by meters per second. With this, you can now cancel like terms, and so the meters in the denominator of the first term and then the numerator of the second term can be removed, and then the seconds in the denominator of the second term and in the numerator of the first term can be cancelled. Thusly, the cancelling looks just like this. Seconds squared over meters, cancel the meters, times, or multiplied by meters, cancel the meters, over second. Then the second squared reduces just to seconds, and then the seconds in the denominator just reduces to 1. And so at the end, you're left with meters is equal to seconds, or distance equals time, which is not true. Therefore, this equation is dimensionally incorrect.